Awesome. All right. Hello, everyone. My name is Mike Metral. I'm an engineer at Pulumi. I work on all the Kubernetes aspects of our toolchain. And today we were talking about Ephemeral Kubernetes on the heels of DeliveryConf, just like Angel did. I'm going to be covering different ways you can work with Kubernetes with CI/CD and how kind of the versatility of Pulumi kind of shines in a couple different ways. So for starters, the common complaint that everyone talks about Kubernetes, everyone is it's too hard, it's too much on-ramp. I don't care. I just want it to just load my app. If I'm an infra folks, I just want it to not fall over. If I'm somewhere in between, I want to do as little as possible. So this is a very recurring theme. It only gets more complicated as the surface area of the API expands. And unfortunately, it's become a huge deterrent to a lot of folks. And for most, it can be overkill. For some, it can be just the right fit. But at some point, if you are in the game of managing containers, you will need some sort of orchestration engine in the piece. And Kubernetes fits that bill, in my opinion. But at the same time, it may not be the right solution for everybody. So definitely keep that in mind. What I'm trying to showcase here is how you as a developer or you as an infra ops folks can really work with Kubernetes on a couple of different planes using the Pulumi toolchain. So what is Pulumi? What is that we do with regards to Kubernetes and infrastructure? So for one, as Angel told us in his talk before, first off, thank you to Angel for giving this talk on us and how that fits in with Circle CI. We're huge fans of Circle CI. Pulumi is modern infrastructure as code. So you were familiar with tools like Terraform, Puppet, Chef, Ansible. These are all tools that essentially were born just as the cloud was kind of getting going, right? So you have the Chefs, the Puppets, the Ansibles that are really mutating state on an actual machine. And you have something like Terraform, which is trying to drive to a declarative state of the world, but using a DSL, right? The HCL language. The common misconception about that is that at some point, you're going to have walls of YAML. You're going to have syntax errors that are going to drive you up the wall. And unfortunately, you just don't have the constructs you need to use and manipulate this, right, from a truly kind of imperative standpoint. So the idea is you have no YAML with Pulumi. Pulumi is a series of SDKs. We're completely open source. We are free and open for community individuals. Where we make our money is for organizations. But all of our code is open source. You can pull down the toolchain and even store your state locally in a bucket of your choice if you are not wanting to use our SaaS. But the first thing that you should notice as someone coming from the Kubernetes world is that this very much kind of looks what you would expect, right, from a YAML config file. You have very much the same kind of structure here. We've actually managed to leverage abstractions because now you have real programming languages, right? We support JavaScript, TypeScript, Python, Go, and we just really support for .NET. So VB, F#, C#. So what we do is we expose a bunch of libraries in the language of your choice. You import that just like you would any other library. Use the same editor that you use the same IDE, use the same package manager, use the same test suites. All you essentially do is just write it in the language of your choice and declare the actual end state of what this infrastructure is. So we use imperative programming languages to drive to a declarative state of what my infrastructure should look like. So very kind of similar to what Terraform is doing in that respect, right? Like if I have 2 replicas, I want 3 replicas, I'm going to keep driving that state until I have to have 3 replicas. But what you get out of code is all of the bells and whistles that developers are grown to love. You have type checking, you have linting, you have error completion, you have jumping to definition in docs, you have unit testing, you have integration testing, you have the ability to create abstractions, encapsulations, to share code, to create libraries, to publish that to package managers, to share that with your coworkers. That creates standards, right? And if I'm the networking team and my colleague is the identity team, they can standardize on what IAM looks like and expose either functions or artifacts that I'm supposed to be consuming, just like I would an import statement. Import my buddy's IAM library, and I consume whatever role they give me, or I consume whatever function they give me to create a role. Likewise, I can lock down networking and say, no one's allowed to create public subnets. No one's allowed to create public IPs on any given resource in that subnet. So depending on how you want to mix and match that, really the kind of gamut is available. And with code, you can manipulate it however you want.
Well, let me ask one question.
Sure.
Like in the Circle CI, do you guys have like native support in their infrastructure, or are they just like downloading, because like for example, in his example, when he did the Circle CI for the GCE, he had to install the GCE, and I saw that you guys were just a call top of it. I mean, as I said, do you have partnerships with them, or are you just that easy to integrate into any CI/CD that's out there?
Right. So I'll show you the demo. I was going to do Circle CI before I knew Angel was showing up, so I switched it up and I showed this in GitHub Actions just to show you another kind of option. But essentially, the Pulumi tool is the tool that's being abstracted to some degree, either in an org, say in Circle CI, or as an action in GitHub. But the idea is just a container. So it's a Docker container that we have pre-built with all of this necessary toolchain for GCP, Azure, AWS, plus our toolchain so you can actually pop in an API token, log in.
But then the back end of your tool, it's just a container.
In the CI/CD, yes, right. It's a CI/CD that's coordinating with our SaaS, or if you're using our SaaS by default. So what you do is when you declare this code, this creates what's known as a resource graph, and that resource graph goes from parent all the way down to the leaf node. And so we'll start creating that hierarchy slowly as it goes, and that gets stored in a state file. That state we by default store it on our SaaS, so we can do locking, concurrent locking of that state file. So if you're working in a team, you don't stomp on each other's changes. And essentially what that tool is doing, the CI, is coordinating that state file with our SaaS. So showing you previews, actually enacting the update, or logging into your account. So similarly, just like we can define Kubernetes code, we can do the same thing for our entire service catalog, really, any of the cloud platforms. In this case, GCP, I'm importing the ability to create a new firewall in a subnetwork of GCP. I create a new VM with machine type X, boot disk this. And what you now have is the ability to declaratively write code in an imperative language and manipulate this and funge this however you see fit, right? So you can tweak this, and any edit, the code is the desired state. So the second I swap out the machine type from F1 micro to an N1 standard, it'll see, hey, there's a diff here that's being changed. We can pinpoint to the exact prop. Because what we do in Pulumi, anything with an API, pretty much we expose it through a library in the language of your choice. So we can think of Pulumi as like an API of many APIs. A bucket of those is like the Terraform providers, so we can tap into that ecosystem. Another bucket of that is we can talk directly into the cloud providers, so like talk to CloudFormation, talk to the templates in Azure, talk to the templates in GCP. And much like that, if you have an API, we have essentially a shell of a provider, which is how we expose each of these utilities in our libraries. So if you have a CRUD API, you can implement your own Pulumi provider. Yes?
Do you have support for, say, self-hosted things, like if someone's using Zen or KVM?
Yeah, so right now we have support for vSphere and OpenStack on the on-prem sort of thing. So yeah, so we can tap into those as well, in addition to the cloud platforms. So what you now have is, with real code, you can preview these changes before they happen. You can make an actual decision to actually enact that. You have a full audit trail because it's code, so you can track it in your source code. You can prove it through PRs. You can merge it. You can reject it. You can review it. And we also have integration for secrets management. You can use KMS on AWS. You can use the vaults on GCP, on Azure, and even use your own ciphertext if you wanted to do something mobile. But more so, what you really then buy is the ability to leverage any toolchain, any platform of your choice, because we are this CLI tool. We can plug into your source code. We can plug into any language of your choice through the libraries that we expose. You can work with many different tools that you already use today, right? NPM, pip, Circle CI, on and on. And we work across all three clouds, as well as Kubernetes and OpenStack, vSphere, and DigitalOcean. So because Kubernetes is just yet another API, we can wrap that in a provider and expose that API through a library. So you now have the ability to create a deployment, with completion as you would expect it, just like anything else in regular code. So to focus on Kubernetes, right? This is kind of like the state of the world. We call this like the cake diagram because this is like how deep you can go and how high you can kind of configure to run anything in Kubernetes. The one common complaint, let's see if I can make it bigger. I can't. I'll show there's a link at the end. I'll show you. So the biggest problem about working with Kubernetes as a developer, as an operator, is that you're never really coordinating your work on a day-to-day to what's actually in dev and staging and prod, right? There's always a discrepancy in environments. So the biggest problem is, I always hear is, I don't know how to do this. This is too hard. It's too complicated. I don't care. I just want something to, take my Node app and just run it on Kubernetes. I am an infra person. I don't know what the best practices is to make sure this is locked down, is secure, that I have complete fault tolerance, that my node pools are going to be configured to a point where I can easily migrate between the two without, downtime. The questions are endless, as you can imagine, because Kubernetes is quite complex. And so you can see that the various layers that you have are quite cumbersome, right? You can work with the infrastructure itself to get the raw building blocks. You can then manage Kubernetes clusters if you're running something like GKE, EKS, AKS. Then once you actually have the cluster up, you have the ability to then configure a multitude of properties depending on what you need: auth, logging, policies, service meshes, et cetera, and on up the stack all the way to get to the apps, including things like, it depends on like English controllers, DNS managers, cert managers. But the cool thing is that because we are an API of many APIs, you can leverage many SDKs, as we've noted on the left, to work with each of these layers of the stack, or mix and match however you see fit. This is only what relates to Kubernetes, but we also expose the full service catalogs of all the major cloud providers. So if you do serverless, if you do just raw compute and VMs, that's also at your disposal too. So one of the, so I can remove this bar. Can I not? I guess not. All right. What I tried to do here is like, what is the bare minimum I need from a Kubernetes cluster, both on the infrastructure side and the cluster, to have a cluster that's both production ready, that's limited privilege, least privilege, right, for the infrastructure identity, as well as the Kubernetes identity. What is the configuration of the cluster itself to make sure that it's fault tolerant, that is segmented by node pools, and more importantly, once that's all up and running, how do I share this cluster, right? Multi-tenancy. There's many properties in Kubernetes that allow you to configure multi-tenancy. At the bare minimum, you need namespaces, IAM for these namespaces, as well as RBAC into the namespaces, and quotas, right? That's the bare minimum. You can't really see this on the bar, but also runtime policies. You can extend that to your heart's content. But on the infrastructure side, that's what most of the ops folks are working with. If I'm a developer, I don't care about any of this junk, right? I just have my app. I want it to store in a container, and then I want to leverage the resources in Kubernetes to make this go live. And even to the point, many people don't even want to learn the Kubernetes resources. They just want to ship a container and be done with it. So as you can imagine, all this setup is very cumbersome if you don't know what you're doing, if you already have a day job and you can't learn Kubernetes on the side, right? If you don't know what the proper do's and don'ts are. And more importantly, this is an evolving surface area that just kind of continues to grow and to get more complex. So the idea behind what we have at Pulumi is that because we have code and we create reusable code, because we can just expose those libraries, we wanted to eliminate as much of the boilerplate cruft as possible while still giving you the raw building blocks. So you can choose to drop down to that native API that you're used to working with, right? Or you can use our libraries, are really helpers. We don't like to call them abstraction because the notion of leakiness is a real thing. It's about reducing the boilerplate. It's about improving the authorship experience. It's about improving kind of the zero to the aha moment, right? So if I'm an ops person, I have my own responsibilities I have to worry with. If I'm an apps person, I have to do my own series of stuff. But as you notice, right, both ops and devs folks are kind of doing the same kind of run-of-the-mill cycles, right? As an ops person who manages infra, they're kind of managing two things: the cloud resources and the Kubernetes cluster, right? So to go back to the earlier point, these are the basics. The cloud person is iterating on identity, on RBAC configuration, on object storage for buckets to store these containers. They're testing it, they're evaluating it, they're rinsing and repeating. With Kubernetes, the cluster itself, they're creating the cluster, they're creating the IAM into the cluster, they're creating the RBAC, the namespaces, quotas, policies, and the same kind of pipeline. I test it, I evaluate it, go back. And eventually, the ops gets to a point where like, all right, these clusters are solid, they're consumable for our apps, right? If they're like a platform team, and then we're going to release that cluster to the apps folks to consume. So as you can see, by decoupling this, because we have code, I can create an abstraction around Kubernetes clusters. You know, this is what our standard Kubernetes clusters look like. No one's allowed to create clusters other than the ops team, and the app folks just consume the credentials and basically a connection string to work with kubeconfig on whatever platform are on their end. So the app developer then consumes that access point into the cluster, and they go off and do their own loops, right? They have to build their apps, they have to test it, they have to run it through make, to pass it into a Docker build, they have to store it in a registry, test that, evaluate, rinse and repeat. Once the app is too fine-tuned, now it's actually the turn, so I'll put that into Kubernetes. If at a standard, right, most applications these days, or at least cloud native, use some sort of persistent disk or volume. They have a config map, they have secrets, they have deployment services, they can have ingresses, they can have a bunch of CRDs. I mean, the list is endless, but they go through the same pipeline. So as you can see, right, both ops and devs are doing the same sort of work. It would be so nice if both of those groups of folks had the ability to write code for whatever it is they're doing, test it, evaluate it, and share it. And that's essentially kind of the happy bridge that Pulumi tends to fill. I'm going to show a demo in a sec, but now you kind of have a high level of what Pulumi is and how we configure infrastructure, Kubernetes clusters, deploy workloads into those clusters, and even decouple that, whatever makes sense. We started focusing on some cool areas that we can improve the developer experience around Kubernetes. So we just released something called Pulumi Watch. Much like I told you earlier, where we have like this declarative state of changes. What you have, it's very manual today. You have to do Pulumi preview. Yes, that preview change looks good. Prove it, do an update, rinse and repeat. Pulumi Watch is kind of an ongoing loop that just never stops. And so what happens is the second I save on my editor, changes get deployed, rolled out into my cluster, I'm none the wiser. So it helps with limiting the mechanics of actually working with this. And it's pretty easy as far as once you have an established pipeline, to just kind of work in your own silo and save, and then it goes off and ships off into a cluster. And that's kind of the mode that most developers want to work in. Similarly, we released a tool that's also in preview called Pulumi Query, where because we have code, right? We have the ability to not only tap into a live cluster, we can actually do fun stuff with it. So if you ever run a Kubernetes cluster, at some point you ask yourself the question, like, how many pods are out there running X version of MySQL? The standard today is to either kube control your way through it or write your own client Go app that's going to be a very tall order, right? If you've never worked with client Go. And more so, it is kind of cumbersome. Luckily, we have some smart folks at Pulumi that were able to cobble what we call query, which is a ability to query a live Kubernetes cluster in kind of two modes, in both batch and in streaming. Batch is kind of like a series of questions that runs to completion, and streaming is the ability to just kind of watch an object change as it evolves through the lifecycle, as it gets deployed into Kubernetes, as it lives in Kubernetes, as it lives or fails and whatnot. So that's kind of the gist of what I have to talk about it. Let's jump into a demo and showcase some of this. Can people in the backseat? No? All right, this is gonna be fun. All right, so two categories, right? Infra and app. So we'll focus on infra first. Angel showed off some of this in his demo. I am also going to leverage GKE because they are the fastest deployer of Kubernetes, so it makes for great demos. I would not recommend EKS for demos. So at the very least, right, in that list I showed you, you have to essentially set up identity, the cluster, and maybe some like default properties into that cluster. That's what an infra team is concerned with. So here, again, we're going to operate off least privilege. I create one service account that deploys the cluster into a GCP project. So these are isolated, entities within Google. You can't control the entire account. So the CI/CD endpoint of this will have project owner and container admin on the project, so they can actually go off and instantiate the cluster. But then we want to make sure that our application developers don't have the same privileges. So we go off and create a service account for them that's only locked down to the following roles. They can only be a storage admin and a admin of the cluster that we give them. The storage admin is simply to be able to create buckets to store your containers in. So we can already be off to a much better start where we can share the same cluster and we can even lock them down to a particular namespace. So in this identity, right, what we are doing is we create a service account for the developers. We give them storage admin creds, get the key, the secret, and create a bucket for them. All pretty straightforward stuff. In the GKE cluster, just like Angel was showing, here we can declaratively state, I want my GKE container to look like, cluster to look like this. I want it to have these labels, these tags, whatever have you, export the kubeconfig file. And in Pulumi, we have the solution provider for Kubernetes. That's just a wrapper around kubeconfig. So all you need in Kubernetes is a kubeconfig file to access it. So that way you can share actual resources around, right, as any object, and have that be interchangeable if you want to operate between different clusters. In that same cluster, we're going to create an apps namespace. Again, you're seeing this all in code. So if you see one of the benefits of like jumping into working with code, I can go see the definition of this right here. I can see that here's what it takes to construct a namespace. And the sizing sucks on this, but I can see what's in a namespace, an API version. I can see kind, I can see documentation. I can see metadata. What's the metadata? Well, I can go to that too.
Is that 9,900 lines?
Yeah, so this is the full API spec of Kubernetes, and we absorb that into a library and expose it to you.
Okay,
yeah.
So that's not a part of the...
This is not a part of, no. This is not a part of the program. So I'm consuming the API that we import, yeah.
Okay.
No, yeah, this is not 10,000 lines of code. Yeah, that would be the opposite way to move. But the cool thing is that we don't create new nouns, we don't create new APIs, we don't create any new resources for you. It's the same resources you've used to work with Kubernetes, we just expose it through language.
But what you're saying, let's make sure I didn't mishear this earlier. When you go ahead and create a cluster, that you guys will actually create it to be a, where you use best practices.
Correct.
So you don't make those mistakes of not knowing the best practices for locking them down.
Correct.
So you can kind of help eliminate some of that, the mistakes that can be made by some noobs. Absolutely.
Not just noobs. I mean, folks in the field, this is a moving target, right? Kubernetes is rapidly evolving. There's many new, multi-tenancy means a lot of different things to a lot of different people, right? And that is kind of at the crux of how to work with Kubernetes. Like the fault tolerance, the making sure things don't fall over, that things are going to stay on, when you're not looking. That's kind of tend to be solved for the most part for you by the providers, but they give you a vanilla shell of a cluster. They don't give you anything else. You just have to go in and configure your defaults and configure multi-tenancy and deploy workloads and share that cluster. So you're not having to worry that that's going to fall over necessarily, but you're still starting from carte blanche, right? And that is always going to be the case. So,
is there imagine that instead of using your library, I use the GKE Python library. Would I see a difference between yours versus the?
So the difference in that, and for example, like I'll use Botto because everyone kind of understands Botto, right? You're still crafting the client from the initial API requests to reading those responses, to parsing those responses, to storing it into your own objects, caching it, manipulating it, etc. That's the full, like, I want to go full tilt and control everything. We are not doing any of that. So here we are talking because, for example, in Kubernetes, it's just an API request. We absorb the entire API into a library and then using kubeconfig plus the client Go library, enact that into the cluster itself. So you're not writing the full client from scratch. You're just declaring, here I'm just declaring a namespace. This looks exactly what it will look like in YAML, except I have the ability to declare a variable and the ability to swap out which provider that gets created in. But this spec is the exact namespace spec. So for the developers, I create a namespace for them. I lock them down because I don't want them to go crazy on my cluster, give them a bunch of parameters that are within range as far as CPU memory and resource quotas and types of resources they can create. And then I even fine tune them down and saying developers only allowed to access these API resources using RBAC roles in Kubernetes. But what you now have is the ability to declare all this, reference these objects. So I not only create a role, I can create a binding that references my namespace, that references also the actual dev role that I created above. And so you try to do this in YAML, you're doing a lot of copy pasting, right? Or you're trying to get outputs to be inserted or interpolated into your manifest of choice. Here, you're just using references just like you would anything else. And similarly, I can lock down not only the namespace and how much they can consume of resources in that namespace and what resources they can consume, I can even create policies that say your runtime is only allowed to use the following system capabilities, right? You're locked down to not being able to tap into the host. You're not allowed to run as a privileged process in the Linux namespace. And you can see that all the way down to through the rest of the configuration we have. So we can, by default, and all this is exposed to you already, like I'll show the GitHub link at the end, but this is based on a bunch of reference guides and architecture that we've vetted that have already worked. We've done this in the field with customers, as well as expertise from the team across the past couple of years of running this stuff in production for Fortune 500 companies that give you a better starting point than just starting from scratch. So I'm running low on time, so I'll fast forward through this. I didn't have time to show the whole CI/CD demo, but as I'm a developer, now all I get is, so in Pulumi we have these notions called stacks. So that program that I showed you for the infrastructure, I have a separate program for apps. An instantiation of that program is what we call a stack. So you can have a dev, a staging, a prod of the same program. It gets to a point where you want to decouple these things, right? It just makes sense. I don't want one massive file for my cluster, my app, you know, all of the defaults. So you break them up into stacks, the infrastructure of the apps, and here I'm actually referencing the output of the namespace I created in the last program. So that cluster is in charge of creating all the properties that I am allowed to consume, do, operate, work within the guardrails. Here I'm a consumer of that based on whatever my administrator gave me. So I'm creating the namespace that was given to me. I'm consuming the kubeconfig file, and the only hackery that is left to do to some degree is really on this. Much like Angel showed in his, let me see if I can find it. Oh, I can't pull it up, I forget where it's at. Anyways, it's just another file to do the gcloud off. So what I get from, as a developer, because I created a lockdown service account in the previous program, I can consume that, and then I authenticate as that user before this program is run. So I can have decoupled pipelines in my CI/CD that creates clusters with particular privileges, that deploys into clusters with limited privileges, and you know, essentially lessen that surface area. So I get the kubeconfig file from the previous stack, I get the namespace from the previous stack, and I go off and create my program. And on this side, right, here's my Node app. It's just a standard Node app. This is a hello world. The left is the Docker file. The middle is the actual main, and then here's a regular HTML file. But on the right is where you got to see really what the kind of the power of having abstractions are. So if you've ever written, you're right, a persistent volume, a secret, a config map, a deployment, a service, you're talking about hundreds of lines of code. Because we have code, we removed a lot of the boilerplate, and you can define all those objects I just mentioned in 50 lines of code. So I can create a new GCP registry here by importing the GCP library and say, so import GCP from Pulumi GCP. I create a new registry, gives me a new bucket, that's one line. I pull down the local file directory Node app. I pull the Docker context out of that, and I have a Docker image builder in code that pushes up to that repository. So I can build it, I can create the registry, I can build the Docker container, and I can push it up in 10 lines of code. Similarly, we took the surface area of the Kubernetes API, we reduced that even further. You can now create a persistent volume claim in 4 lines of code. As you can imagine, if you've written this, there's metadata fields, there's all these fields that need to be filled in. We need to take care of all that. Mind you, if this is too limited for you, you have the raw spec at your disposal to always drop in and use that full spec. Likewise, we've done the same thing with the config map. So I only care about defining my data as to be some object, right? Here's a key value. For a secret, same thing. We even have a random generator that would generate 2 random entropy-based passwords, sort of that in the Kubernetes secret. And as you can see, right, like here, this is the KX package we have. The K8s is the full API that you're used to working with. We just have an extension that lives on top of that removes a lot of boilerplate.
You guys take the programming language and then convert them into YAML files and then pass them? Into
Straight API.
Straight API.
There's no YAML involved. There's no JSON. There's no nothing. So that's one of the alleviates of you never have to touch these DSLs ever again. And we came up with this notion. The team toyed around this for a while of how to best encapsulate this. And if you've ever written a deployment and a service just on those two, you're looking at about 70 lines of code. And we have this notion of called a pod builder, and that is just the basics, right? So even with defining environment variables in Kubernetes sucks. Like this is a very tedious object-oriented syntax manipulation you have to play with. It should just be a key value. So we made it a key value. Your image should always reference the, again, we're working in code, so we're referencing the image we created up earlier. Volume mounts. It should just be as easy as passing a persistent volume and say, mount this thing on this endpoint. There you go. So this is the crux of the container, right? This is one container, I can create an array of them. And a deployment is as simple as saying, here's this pod builder, which is our root object on the bottom to construct this, spin it up 2 replicas. If that's not enough for you, you can always drop into the spec and see the full spec of Kubernetes as you would expect it. And there you have it. You have namespace, you have the spec, you have the metadata, you have all the stuff that you're used to working with. And likewise, a service should just be the ability to expose a certain kind on a deployment. So the service here is 3 lines. It says, take this deployment, throw a load balancer type service in front of it, get me the endpoint, spit it out. So in all of this 50 lines of code, we've reduced so much boilerplate, and we create the exact semantic output that you need for each of these resources. We don't create new nouns, we don't create new resources, we just remove the boilerplate. Question?
So if you're working in pure JSON, are you able to do, if you're not working in any JSON, are you still able to do custom resources?
Yes, so the CRDs are just another endpoint on the service area, right? So you can define the CRDs in code as well, yeah. And you can import them, yeah.
Oh, what's the deal with line 63 right there?
Line 63.
Yeah, are you putting this in source control?
Yeah, this is all source control. No, so mind you, if you've ever worked with Kubernetes, a secret's not really a secret. It's a config map running in a tempfs. So it is. So this is essentially referencing that. This is obviously bad practice, right? You would not want to do this. You would need something like a Vault or a KMS or something along those lines. But the idea that I'm showing you here is whether this is password, this is random data, to seed something, you can just reference it as an environment variable rather than having to craft a bunch of specs across the board and copy paste that. Question.
So what you're proposing is that, like, when we saw Angel's presentation, when we saw his files, we saw a file for Circle CI, and then we could see files for Terraform, and these files look different. But what you're saying is that for a developer, they could be working on files for their application. They could be working on files for their infrastructure, and they could be working possibly for files that are on their process as code, which would be the Circle CI. But the first two, the application code and infrastructure code, are in the same language, which helps people understand what the hell's going on with Kubernetes.
Correct.
Because you're going to make your Kubernetes cluster from scratch, put the application on it.
Yep.
Which I find quite fascinating, because the company I work with, the Kubernetes clusters are out there, and you're always putting
Stuff into it.
Yeah.
Right. So to go one step further, you don't have to use the same language. So I can write my cluster in TypeScript, and my application developers can describe their resource for their app in Python. Because right now, all that's being shared is the output of that cluster, the key-config, and what namespace am I supposed to be working in. I can consume that however I need. So you don't have to use the same language if you don't want to. Question. To your other question, sorry.
How do you execute this? How do you deploy it?
So the Pulumi tool is essentially it, right? So I will, since I'm already out of time, here I want to show you a quick change, like on the infrastructure developer. I had a whole thing with GitHub Actions, but Circle CI actually has way better documentation. So I actually had that running quicker than GitHub Actions. So shout out to Circle CI for getting their ish in order. So for example, if I decided that I wanted to make the developer not only be a storage admin, I want to say they also can do like Cloud SQL or whatever. Someone help me out. Is it roles, Cloud SQL admin? On the right, anyone, GKE? Yep, yep. Okay, so that is a single line of change. I can do a Pulumi preview. It'll hone in on the exact property that's changing. So it says I'm going to create a profile. Oh, that's not good enough. Let's show you some more output. I can see a full rich diff. And you can see that I'm actually adding in this object a new IAM binding to the roles Cloud SQL.admin. We have a panel that shows you all of that with regards to so how this looks like. So I can see the preview of this. Similarly, in my dashboard, I can see the rich diff. And if you're working across an org, you can see like who did what. I changed this on this commit, link to that commit and whatnot. And even more so, you have the ability to enforce policies at a governance level. So I can say, hey, no one's allowed to spin up an S3 bucket with a public endpoint. No one's allowed to create a service on Kubernetes that has a load balancer. Yes.
All the way back.
Yes, yes.
So I think the question was asked about custom resources, and this is sort of related, but clusters evolve. In other words, you may have auto-scaling, you may have out-scaling on it. So, nodes go up and down, pods go up and down, other resources move around.
Right.
How does Pulumi react to that when you in terms of, for example, the preview that you showed, but also when you want to go and change something, knowing that the state may have evolved since the last time?
Yeah, great question. So I have two answers. So let's look at the infrastructure and then we'll look at the Kubernetes piece, right? So if I went in and said my VM is of machine type, whatever, N1 standard, and I decided to, stand that up, and then you came into the dashboard on AWS and you said, delete the virtual machine. So the state of my world thinks that that VM was created. You went in to the back, deleted it, and now it's gone. Next time I have the ability to do a Pulumi refresh, and that is something that you would run either before a preview or before an update to get the state of the world based on it's basically comparing what it thinks the state of the world is versus what the reality is, and then trying to reconcile that. So that's on the easier side. That's because we have we have an insight into the API through AWS. For an HPA, for example, like horizontal pod autoscaler in Kubernetes or any controller for that matter, these are controllers whose states fully live in etcd. So we don't have that access into etcd, nor should you expose that, right? Because etcd is the keys to your kingdom here. So even that is operating in a fine window. Like GCP will say, like, if your HPA is between 2 and 5, it's going to potentially spike up to 7. It may spike up down to 2. You may have an average of about 4 or 5. Even they don't necessarily make a claim as to how many nodes you're going to have at any given time, right? Because it's based on burst, it's based on availability, based on utilization, and based also on your account status. So that's the sort of stuff we don't have an insight in and we can be better in. But the reality is it's a very kind of murky problem because the controls in Kubernetes are just in a mind of their own, right? And there's too many of them. Couple that with too many CRDs, it's just too big of a surface area for us to kind of have a good foothold in. Where here, as you can see, the state of the code that I'm writing is what I'm expecting it to be. I can deploy an HPA, but beyond that, I'm kind of walled off from that.
Is there an ability to then just ignore certain things for the purposes of a refresh and that type of thing, where I say, I know nodes are going to change. Let me not look at that. Let me look at the other services.
Yeah, you can ignore changes on certain properties. Yeah. Question.
And so for configuring a Kubernetes cluster, I saw your libraries doing a great job through Python. Very happy. Yep. For managing the life cycle of the cluster, I saw your libraries calling on the DKE APIs through a wrapper. Are you guys planning to abstract that part? Say, for example, using cluster API?
Yeah, so cluster API is a good question. So for those who are familiar, cluster API is basically I feel like every year we in the community reinvent how we are instantiating clusters, right? Cluster API is the current effort that the community is putting their weight behind. We have our eyes on it. We don't have any opinions on it necessarily, just because it's still an evolving space. We are in the mentality that to some degree, right, like unless you're on-prem, the cloud vendors are kind of one in the space, right? And it's easier to just swipe your credit card than it is to try to be an SRE for one of these things. So the reality is, if there's enough meat on the bones from a cluster API perspective that it makes sense for us to integrate, absolutely, it's just another API, right? So if it's an API, we can wrap it in a provider and expose it through our library.
So in the same way that you have GKE there, and you have also Azure.
We have Azure, we have AKS, yeah.
How easy it is is for somebody, either you guys or somebody else, to come in and create another one of those libraries for any other API, say for example, some other OpenShift.
Yeah, so exactly. So we've actually got a request for OpenShift. So anything that has a CRUD API is pretty much one of the easiest things we can do. So we have providers for F5. We just added support for DigitalOcean. I mean, if there's an API, we can wrap around it. So for the most part, right now, it's kind of like Pulumi employee guided, right? Because it's still kind of a novel space. But we do have customers that are actually writing their own providers. How costly? I mean, we have documentation. I think people have spent something like 2 or 3 days to get something going. So that's a matter of days.
How closely are you trying? So I imagine you're creating objects in your API, right?
No, so we don't interface at all. We don't touch your creds. We don't touch your API. We just, the API requests initiate from your client machine. We build up the graph, and we just make sure that graph is matching what the request from the client is actually.
Sorry, what I meant to say was that you may be instantiating, for example, like the ingress object or whatever, right?
Sure.
Pulumi, but like, how closely are you tracking those relevant backend sort of clients, right? Like if they change at a.
Sure, you mean the controller itself is like evolving? Yeah. So if it's a native first-class citizen resource, then that's what the Pulumi refresh will do, right? That's what's fetching the state at that current moment, and then going to actually enact it when you do an update. Obviously, there's a window of time that if I happen to like switch the hood under it, right, what I'll get is a failed update. But the thing is, we do a create before deletes. So we have to completely create the resource in its totality, get a secure, a guarantee on the transaction, and then we'll tear down the old stuff. But until that creation completes, we don't bother with that. So we do it in a very safe way.
You do it like naming context, like certain things cannot have like,
Right, so by default, all of our resources, we append like a suffix, like a random suffix. You can disable that if you really want to kind of like control the naming of it, but we do that as a safety default, so you can have the same, VM with the same profile, instantiated in a for loop 100 times if you wanted. Cool. Question?
Yeah, one of the questions I had was, earlier you stated the one thing that differentiates you from a product like Terraform was that you guys can utilize any programming language like Python, blah, 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 blah. What are some of the other key differentials that separate you from another product like Terraform, which might be a little bit more mature or have been around a little bit longer?
Yeah, definitely. I mean, let's be frank, right? Like, we are standing on the shoulders of giants here, right? Like, Terraform was the first mover. They've instantiated a movement of being proactive about how you declare infrastructure and how you manage that infrastructure. The reality is, anyone who's worked with Terraform long enough, the management of that YAML, or the HCL really, becomes cumbersome, it becomes a pain. It becomes even more of a pain when you're working on a distributed team. There's always hackers. There's a bunch. I would say there's not just HCL there. There's a bunch of glue code and bash scripts helping prop it up, right? And so that is unfortunately the state of the world. But they have set a precedent really for how folks should be managing infrastructure, and we should not take that lightly, right? Like, the reality is now we kind of were born also in the post-cloud era, right? They were born 10 years ago with Vagrant was kind of the early onset of that. And so now there's more paradigms that are kind of first-class citizens to us, like Docker containers. So as you can see, we can build a container in one line, we can push it to registry. Like, those are functionalities that are going to require a bunch of HCL, and it may not be as fluid. Not to mention, you have no referencing, right? You can create modules, but I guarantee you pluck 2 people out of here, their modules are not that reusable or not that interchangeable.
Well, because in our Terraform, I mean, it almost becomes a nightmare with all the different files that you can have everywhere. And you guys overcome a lot of that problem?
Yeah, so funny enough, we have the ability to, and I'm running out of time already, way past over time. We have the ability to convert Terraform to Pulumi. So like, we convert like 90-ish% of it. So you don't have to like boil the ocean. I'll be around if anyone has questions. Turn over to you.
Awesome. Okay. Thanks so much.